Hello, everyone, and welcome to our Ray Summit Talk, how Spotify sped up ML research and prototyping with Ray. And my name is Kashi. I'm a senior engineer at Spotify, the machine learning platform team. And this is my colleague, David, and another senior member in our team. Today, we are going to share our Ray story in ML research and model prototyping at Spotify. So machine learning is at the heart of almost everything we do at Spotify. Its applications include recommending personalized content on homepage, optimizing the ranking results from the search, and helping you discover and explore the new music you haven't listened to before. To power ML products at Spotify, our team is building and managing a centralized machine learning platform that provides our engineers with tools and environments to quickly productionize ML applications. Our production ML platform internally is known as Kubeflow platform. It has two components, a Python SDK for building ML workloads with TFX standardization, and several managed Kubeflow clusters for ML pipeline executions. For those who don't know, TFX, TensorFlow Extended, is a component-based ML framework for TensorFlow ecosystem. Kubeflow is a set of machine learning toolkits on Kubernetes. So Kubeflow platform, as a successful product at Spotify, offers a paved way to solve many standardized ML problems, especially for supervised learning on tabular data sets. However, one feedback we constantly hear from our users is that TFX is very difficult for ML research and model experimentation because it's a very opinionated framework and optimized for the ML production systems. In addition, with growing numbers of ML practitioners and ML applications at Spotify, how to provide tools to help our users to solve all kinds of ML problems become more and more challenging. It's a problem of the long tail. And TFX component-based solution does not offer sufficient flexibility to leverage popular and state-of-the-art ML packages. It's a closed ecosystem. So it's hard to integrate other open source tools to serve broad groups of users. An ideal ML platform should cover both depth and breadth and offer a wide range of tools to tackle different problems in a scalable, maintainable, and enjoyable way. A modern complex ML system needs contribution from ML practitioners with different backgrounds. It needs research scientists to prototype and experiment new ideas, data engineer to explore and optimize features, ML engineer to implement productionized models, and the data science to analyze A/B test results, and the backend engineer to service model in production. Our platform should accommodate all their needs. So earlier this year, we started evaluating Ray. We believe with Ray and its broad ecosystem, research and data scientists can access more popular and familiar libraries. It can help them quickly start projects, build a prototype, and experiment different ideas. This example shows how to use attributes, scikit-learn, and smoothing on Ray. It shows how Ray can help our data scientists using their familiar libraries without sacrificing the scalability or rewriting code in order to work on a large data set. All they need to do is change the import from pandas to smoothing.pandas. Users don't need to change their code. And the interactive development experience with the distributed computing power speeds up the feedback loop and allow users to explore, experiment, and validate their ideas. So one of our users was able to accelerate their offline evaluation workflow on Ray just in 2 hack days without any previous Ray experience. They saw 6 times speed up in offline evaluation experiments using smoothing and the Ray core library on large data sets with multiple models and metrics. And next, I would like to show you how Ray simplifies the ML stacks to speed up the ML development productivity. As you can see, a typical TFX pipeline involves several very different layers, including TFX, Kubeflow, Kubernetes, and different GCP services. When users write ML workflow, they start with TFX DSL by assembling the components. Then the workflow is compiled to a Kubernetes YAML file for the job submission. When it runs, each component follows specific TFX logic for the execution. It either calls out GCP service to run the workload or use the Kubernetes pod for distributed computing power. With this approach, it's great when everything is working. Folks can quickly solve the standard problem with pre-built components. However, when it's not working, especially when developing customer logic, users spend a lot of time on digging into those logs from different layers, from different services. They are trying to understand where the error is from. Is the error from my code? Is the error from Kubeflow pod? Or the TFS component? Or it's from the data for workers or AI platform? Users need to know all those for debugging and to build their own logic on top. So research and data scientists need better tools to speed up their development productivity. So with Ray's unified API for distributed computing, it's simple and intuitive to configure resource for training, prediction, and data processing. Less Kubernetes knowledge is required for research and data scientists. All they need to know is the number of CPUs and GPUs for their workload. With the Ray 2.0 release, by defining a scaling config, we can conduct distributed training for XGBoost, TensorFlow, and Hugging Face, and more. In addition, Ray application is a regular Python program, and users don't need to learn other frameworks or different set of APIs, or even Kubernetes to leverage distributed computing power. This simplifies ML stack so users can spend more time on iterating the actual ML problems. With all those benefits we have discussed previously, we believe Ray can help us diversify ML practitioners and offer users a unified experience for ML model prototyping and experimentation in a scalable and maintainable, enjoyable way. And we position Ray as a managed distributed compute platform that enables ML research and experimentation for non-standardized ML workflows that cannot fit into the TFX paradigm. With Ray, we envision two major user journeys for research and data scientists. The first one is for model prototyping and ad hoc experimentation. So research and data scientists, even MLEs, can tackle different problems with the help of user-friendly API and open source library. The second one is around supporting production paths for offline batch prediction for non-standard ML workflows. Users can use Ray to prototype and productionize their workflows. To support the above two user journeys, we have been collaborating with teams to build POCs on Ray to solve real Spotify problems. POCs include training GNN embeddings for podcast recommendations, scaling reinforced learning for radio stations, and XGBoost for A/B test user segment analysis. These POCs have formed our initial design for our managed Ray platform. It contains two components. The bottom layer is the managed Ray infrastructure built on GKE. Every team can have their own dedicated namespace to host their Ray cluster to run the Ray applications. We are using open source kubeRay to manage Ray cluster in each user namespace. On top of it, we also offer Spotify Ray Python SDK for users to interact with our managed Ray infrastructure. It also provides the integration with other ML platform services, Spotify info ecosystem, such as metadata, experiment tracking, as workflow orchestration, and scheduling. By leveraging Spotify Ray, users can use popular open source libraries and community support to build ML application to drive the business impact. As a platform team, we own and manage the Ray infrastructure and the Spotify Ray SDK. User and the product team, they're going to own the ML applications built on Ray. In this quarter, we are working on Spotify integration and aim to release the alpha version in Q4 to broaden the Ray adoption at Spotify. So lastly, I would like to highlight the business impact driven by our POC work. With the help of Ray, the idea of using GNN for podcast recommendation results in online tests in less than 2.5 months. A daily batch prediction workflow has been productionized with just in 2 weeks for an A/B test at MAU scale. It created a foundation for standardizing GNN prototyping at Spotify and helped research generate more ideas and experiments with better modeling experience. For reinforced learning, Ray unlocked the performance bottleneck in IO agent training and paved the foundations for upcoming productionizing the offline IO workflow. Now I'm going to hand over talk to David, and he will talk more about Spotify Ray we have been working on.
Thanks, Keshi. So Keshi went over why we're using Ray at Spotify, and I'll go a little bit more into the details of how exactly we're using it. So we had 3 options that we could think of. One was using a third-party managed service, like the hosted AnyScale one, letting individual teams manage their own underlying infra. We just provide some libraries. And then lastly was like a hybrid approach where individual teams would only have to care about their Ray clusters, and it would be a centrally managed multi-tenant infrastructure platform that we provide. And so we picked the third option. The first option wasn't so attractive because we have a lot of internal Spotify stuff, and using a third-party hosted service, we still have to build out all those integrations, which would be pretty costly, and we'd lose some control over exactly how the service was run. And the second option was not really acceptable for us because we know that a lot of these data scientists and researchers, their specialty is not infrastructure. They don't necessarily know how to run Kubernetes, or just VMs in general. So we wanted them to be able to focus on their business problems, which was modeling and experimentation. And so we picked the third one. Some of the benefits of that are that it centralizes the infrastructure and integrations. We would have more control over it and can customize it better. And again, individual teams can just focus on business problems. So how do we deploy Ray? We use the kube and we deploy it onto Kubernetes. Like Keshi said, we use GCP a lot, so our Kubernetes clusters are all in GKE. And right now they're just, it's like a multi-zonal GKE cluster. We've set up a bunch of different node pools with a bunch of different GPUs, like T4s and V100s. Made it so that it could scale up to a pretty decent size. And one of the things we optimized for was just fast container image downloads. This is cloud specific, but there's some stuff in GK that makes it so that it's called image streaming. Your images can just download a lot faster because we really wanted that experience of scaling up your number of workers to be fast, or container start times to be fast. We don't want people even to wait minutes or something. And then the multi-tenant design we have, each team creates their own Kubernetes namespace. That's kind of the only time that they really have to bother with Kubernetes, but after that, they don't really have to care about it. So namespaces here are used to leverage for resource isolation and granular authorization. We can use all the regular Kubernetes RBAC to give control to the Ray cluster CRDs to users, but we don't give them lower level stuff so they can't mess around with the Ray system namespace or lower level Kubernetes things. We don't want people creating daemon sets for no reason. So we built a very, very thin, we try to keep it as thin as possible, CLI and SDK on top of kube and on top of just spinning up Ray clusters on our GKE cluster. And the goal here, again, is for data scientists and researchers to abstract as much of the underlying infrastructure away from them as possible. Things like Kubernetes, things like GKE-specific stuff. We wanted to make it easy, intuitive, and extensible CLI and SDK, so to manage and interact with their Ray clusters. And also in the future, we're going to add more integration with other Spotify internal ML services and infrastructure, like, for example, experiment tracking, which we have an internal system for. And so what does the CLI look like? Again, this is very simple. It's all written in Python. And you can just do sray, create cluster in a certain namespace. We have flags with tutorials, which actually start a Jupyter notebook server, upload some tutorial notebooks, and then they can just click. I'll demo this later. They can just click. It'll open their browser, and they can just hit run all cells, and then that gives them a quick hello world experience. You have list operations. You have a delete operation to get rid of your cluster. Describe cluster command will actually print out some useful information, so you don't have to look at Kubernetes YAML or even have to know how to use kubectl. It shows you head IP, there's notebook server, dashboard, your head group, how many worker groups you have, replicas in those worker groups, and GPUs and CPU resources. And it's easy to customize basic options. So when you create a cluster, you can specify how much resources you have, types of GPUs. For anyone who, so there's a little bug here I noticed today. When people create a cluster, sometimes they specify way too many resources, and our node pools actually can't handle that. So if anybody has ideas for how to make this better for us, we don't do any validation right now, but we want to do some validation. So if they request some type of GPU or number of resources that we just don't provide in our node pools, we'll just say we can't create this cluster. Right now, the cluster looks like it's being created, and it just spins, waiting for it to be ready. And then we have to tell them, oh, your pods are never going to be scheduled. And that's where the abstraction is leaky. So if you have good ideas about how to improve this, let us know. We have a command to scale your cluster. So you can just scale a worker group up to n replicas. And if you are a power user and you were I know Kubernetes, I know all the YAML fields and what they do, we still let you drop down to that level. So if you want to configure 2 worker groups or have very specific requirements over your array cluster, you can drop down to the YAML. You can just edit a YAML file and pass that in. So the idea is not to prevent that, but to make it so that you don't have to know. And I'm going to switch over to a demo, pre-recorded demo here, of how it looks like. So hopefully this is big enough. The resolution is a bit low. How do I get? OK, well, it's 1080p. That's the best I can do. Let me know if it's too small. Anyways, here, the first one was just listing a cluster in the namespace. The second one, I'm going to create a new cluster. Sorry, it's blurry. But here I'm using the file-based approach, so it actually uses a YAML file. Oh, got it. The resolution came up. So now it's starting. I passed in the with tutorials, it's starting the tutorial one. And if you see, I click on that link in the terminal. It's going a little fast, but it opens up the Jupyter server. There's some preloaded tutorial notebooks that just give you a really quick introduction to Ray. So we wanted this hello world experience to be really slick. No coding involved, one command, hit run, and then people can just see how easy it is to scale up their Python code. And then we have more advanced notebook tutorials here. This one shows XGB and TensorFlow. And then some random recommendations. I wish there's a better way to embed videos. OK. So that's the CLI. And then there's a corresponding SDK. So if you don't want to use the CLI, you want to do it all in Python, it's almost a one-to-one equivalent stuff for it. You can create a cluster, you can scale a worker group, you can delete a cluster with almost the same exact options here. And the goal again is to abstract away Kubernetes, so you don't have to import a Kubernetes Python client or anything. Some use case-oriented Ray setups. In the future, we want to offer use case specific things, so users don't have to figure out all the boilerplate. So that could include container images with pre-installed dependencies, tutorial notebooks for different types of frameworks, you want to use Hugging Face, we have a tutorial for that versus XGB, and then tailored compute templates. So if you want to do feature processing versus training versus evaluation, you might want to have different resources or even different types of GPUs that are specifically tailored for each. And we want to make it easy so that you don't have to think a lot. There's kind of just a template for that. And future integrations that we want to work on. So standardizing the Spotify ML platform experience. We want to be able to let users track experiments and metrics in an internal ML dashboard, integrating with internal ML metadata. And we have an internal feature store, so showing people how they can just use Ray and get access to that as well. And other parts of the Spotify ecosystem, like scheduling your workloads. So we have a team that manages a flight cluster. So we were building out a preliminary flight integration with that. There's also internal data endpoints not related to ML features usually that people can also tap into. And then for us on our side, like bookkeeping, we want to have good cost tracking and attribution. All of this is run in a multi-tenant single GCP project, which makes the billing look kind of funky, like our team is just spending way too much or something. So, but there's GCP features that allow you to segment by like a Kubernetes namespace. So we want to make sure we do the cost attribution correctly. And then as always, we're going to improve the infrastructure's availability, reliability, and performance throughout all of this. What is this? Oh yeah. This is a little out of order, but this is the flight stuff. This is a little. I think I added this in last minute, but this is like an upcoming flight integration. So you can add like a array job config. You can schedule it, and this will just run like a flight workflow for you. And then during this workflow, it actually creates an ephemeral array cluster and tears it down at the end. We want to give thanks to the community, so that's AnyScale and the Ray project, like Richard. These are just happen to be some call-outs for the people we've worked with, but it's not an exhaustive list. And then from QRay, there's Jiaxin San, Dimitri Gekman. From Union AI in Flight, Kevin Su, Yi-Hing Tong, and Kitan Umare. So thanks so much for coming to our talk. We want to give plenty of time at the end for Q&A, so don't be shy. Ask us anything or even suggestions about how to improve.
Hey, thank you for a great talk. I was wondering, with respect to teams that are spinning up their own namespace, you mentioned that in the future you want to create container images that are use case specific, but at the moment, if a team wants to specify dependencies, how might they do that?
Yeah, so it depends on the dependency. Sometimes they can like pip install, and then they have to restart their notebook kernel. With Ray, you can like say like the runtime env, kind of like what's going to be installed in your workers. Are there maybe other dependencies that are like lower level that they would need like a custom image for?
And with the custom image, are they just taking the base Ray image and then using that, or are you?
We added a few. We added like a few small things. For example, I added like just this morning Open VS Code server into the Ray base image. Yeah.
There's also some teams, they doing some crazy stuff. They also do the other way around. They have their own base image, and they install Ray on top. And in the KubeArray, they also have a compute like templates. You can define the templates for different worker type. Then you can create those config and start them as a Kubernetes config map. Then when you spin up the Ray cluster, you can also use those templates to configure different workers.
Thank you.
Hi, I want to know if you are using Reserve, and if if you're using Reserve, what's your usage scenario for integrating with the Reserve?
No, we currently not using Reserve, and Spotify has our own like serving infrastructure. We're using TF serving, and our backend service running JVM, but we do see there's tons of like potential for the Reserve, especially like thinking about very big models. You need to fit model into the memory. Yeah, we're definitely very interested and looking into that. Yeah.
Great talk. So I used to see a lot of Spotify talks about Spark. I wonder if you guys still use Spark, and if so, what is the kind of balance of Spark to Ray? Like, how do you work with them together?
We don't have Spark. Like Spotify internally using Dataflow for the data processing, but we don't directly use the Beam API. We have the Scala version called Shield, which built on top of Beam. That's what we use internally for data processing. The vision we have is data ETL is using Shield on the Dataflow or BigQuery. There's other tools for that. Then when you build a fat feature data sets, then you load into the Ray system. Then Ray take over from there. You do the feature processing, data validation, then you train and predict.
Thanks for the great talk. I'm just wondering, like, do you have any thoughts on how to manage the quota? Let's say, like, you have multiple users sharing the same node group, node pool, right? And looks like they can create recluster, like with unlimited resource. So any thoughts on how to manage this resource limit?
Yeah. So one, there's multiple levels here. One is we're just going to use Kubernetes like resource quota, set it at like sane defaults for people who create their own namespace, and then maybe some teams are more important and they're doing some like mission critical stuff that just needs to scale out a lot more. We can, with our approval, they can bump their Kubernetes resource quotas as well. Then not a level deeper than that, we also have like GCP project quotas, and sometimes if we run into those, we ourselves, the platform team, would have to make a support case and ask Google to like bump those quotas for things like GPUs. Yeah.
Another thing I want to add, just provide so default options as many as possible, like with some guidelines, so user doesn't need to come up some random numbers to when they spin up the Ray cluster.
Mm-hmm.
Thank you. I really appreciate at the beginning your breadth and depth contrast, and I found it very interesting to kind of contrast that against some of the discussion Anyscale has had around kind of end-to-end one platform for everything. It sounds like you all have really looked to get the tools that users are actually using, specific libraries, support, et cetera. How do you kind of reconcile your choices of specialized tools or specialized tasks, like you were talking kind of splitting your beam and your Ray workloads, with kind of some of the Ray vision of kind of being the monolithic platform for everything?
Yeah, that's a good question. There's always like balance you're trying to make off. From the platform perspective, we need to consider like how many engineering resources we have, how many tools we can support, but from the like ML teams, they just want to use as many tools as they can. So it's more about like two-way communication. We need to let them understand like the potentials from our platform. And we also build like strong standardization. So make sure our platform is more adaptable for like the industry change. When there's new tools coming, it's always easy to plug into our platform.
Yeah. I would add to that, like a major part that we didn't cover in this talk is like the Spotify specific constraints we're working in. So like the size of the company, the number of users that we have on our existing ML platform. We didn't want to destabilize it or cause confusion, so we had to be very kind of specific and nuanced in our messaging, both to our potential users and also to like our managers of what Ray is and what value it can provide. So there's that. If you're working at a smaller startup where like you have 5 MLEs and like a couple of data scientists, like you can just go hog wild and it doesn't really matter, right? So, but for like a public company at Spotify, we have to make it so that we're introducing it slowly and learning as we go instead of like a big replacement. So you notice in a lot of the other talks, like the keynotes, or the Air talk, they said, oh, you can use Ray to replace like a piece of your platform or like the entire platform. We're not even doing that. We're just standing up like almost like parallel experiment on the side.
Hey, so your last answer was interesting to me. So you guys were using TFX before, and I'm sure there were many teams building models that are running on TFX. Mm-hmm. In your view, what's been the biggest challenge for those teams to then migrate over to this new system? Because TFX, if you're in the TFX ecosystem, it gives you everything. And if you're asking a team to now say, hey, move out of that into this new framework that I'm building for you, what's been the biggest challenge?
Luckily, we're not asking people to do that. So we've been very careful in saying, if you're using TFX or like our SKF wrapper around it, and it's working fine for you in production, don't migrate. We're actually first focusing on people who just can't use that at all. And they're like, I need something, I want to use this learning framework, and it's completely unsupported. Those are the people we're working with for the Ray stuff. In the future, we'll see what happens as we collect more information.
Yeah.
Thank you.
I just had a question about tearing down clusters that users start, because you said you chose the number 3 dedicated Ray clusters on the centrally managed multi-tenant. So do they have like a lease? How does that work? How do you get users to spool up and shut down?
Oh, like if they forget about it?
Yeah, we have lots of users that are like, yeah, I need 300 gigs of RAM, and then they just leave it over the weekend, and their CPU 0. And then there's another user, in Asia that's like, why doesn't my thing work? Because the guy didn't reset his notebook or whatever. So. Yeah. How do you guys deal with that?
Yeah. I mean, one idea we have is you can basically, that one feature we think about, you can probably add a TTL for a Ray cluster. So when you spin up, you have a TTL preset for your cluster. Then you hit the TTL, there's some mechanism you can check it's okay to shut down the rate class or not. If user would like to expand the DTL, they can also do that. Yeah.
Is that done in your interface, or is that just the Kubernetes setting?
And probably we're going to build our own operator to running in the background to do those housekeeping stuff.
Yeah, yeah. We plan to have a bunch of like GC for it, but at Spotify, like usually cost is a lower priority than just developer productivity. So then also on our roadmap, like the GC, all that stuff is also kind of after getting people to use it. Once we see like what we think might be too much waste or just forgotten resources, we'll then go clean it up.
So this will be the last question.
In similar lines, like so resource utilization is a big question for me. Like I know people spin up machines, and then there are ways to basically, like you mentioned, we can spin them down automatically based on the time. But when it comes to like data scientists or engineers using the right resource, like for example, if you have a GPU machine which is like super underutilized, how do you monitor and basically make sure that they're aware of this underutilization, and how do you make sure that it is properly utilized? Even CPUs or multi-node GPUs or something like that.
Yeah, that's a good question. And definitely we need to add more like observability on our infra, especially how the resources are utilized by different teams, by different projects. That's something we're gonna need to build. Like it's on our roadmap. We're probably gonna working on that in next quarter, Q4. Yeah.
Some ideas I can think of are, it's really easy. Developers busy, they forget. So some kind of push notification to be like, hey, you've got like X amount of resources just idling. Do you still need it? And then just nudge them that way and ask them to clean it up if they don't need it. Yeah. But it's a hard thing to figure out. Yeah.
It's also like, for example, if we implement cost tracking, like every team can know, hey, how much money you have spent on your rate class last week or yesterday.
Yeah, then we can offload that work of nudging them to like our tech procurement, who's like, hey, why are you spending this much?
Okay, thanks everyone for coming. Please give a round of applause to our speakers.